Okay, good morning, everybody. So what we are going to do is go through here, section 3 of the math test. It's the no calculator section. Here I just wrote a couple of formulas that might be helpful for you guys when it comes to the SAT. The compound interest formula, the percent change, I know we've discussed that one a lot, and the quadratic formula. So if you want to take a second to pause and copy those down, just as another helpful hint for the SAT, you can, but in this part, we're just going to go through all of the questions in section 3. So for starters, a painter will paint n walls with the same size and shape in a building using the specific brand of paint. The painter's fee can be calculated by the expression NKLH, where n is the number of walls, k is the constant with units of dollars per square foot, L is the length of each wall in feet, and H is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, we're talking about more expensive, we're talking about definitely money. So we can kind of go through it. N is the number of walls. That has nothing to do with the money. K is the constant in units of dollars per square foot. So that has money. L is length, H is height. So the only thing that actually has to deal with money is K, and that's why the correct answer is K. Number 2, you have 3r is equal to 18. What is the value of 6r plus 3? So if 3r is equal to 18, then in order to find the value of r, I want to divide both sides by 3. And I get r is equal to 6. But remember, 6 is not the correct answer because I want 6r plus 3. So do not fall for that one. 6 times 6 plus 3 is equal to 36 plus 3, or 39. So the correct answer is D. Number 3, which of the following is equivalent to a to the 2/3? A to the 2/3 is the same thing as D. Now, why? Because anytime I have a fraction as an exponent, so let's say, for example, I just had a to the 1/3, that is always representing the cube root of a. If I have a to the 1/2, that's the square root of a. And if I have a to the 1/5, that's the fifth root of a. So the third on the bottom is a giveaway that we're looking for a cube root. So it's either going to be this one or this one. And then because it's just a to the power of 2 on top, like 2 over 1, it's the same thing as just a squared, not a to the 1/2. If that 1/2 was the exponent, so 2 was on the bottom, then it would be C. But in this case, 2 by itself can be written as 2 over 1. So that's why the answer is D. Number 4, the number of states that joined the United States in between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between 1976 and 1849, and X states joined between 1850 and 1900, which of the following equations is true? So we kind of go through and say, okay, these years, 1776, 1849, these years, 1776, 1849, so those kind of represent the same thing, is twice the number of states that joined between these years, which are supposed to kind of match up with those ones. All right. So we're trying to figure out which equation this matches up. So in 1776, we're going to call that time span A. And in 1850 to 1900, we're going to call that time span B. And the amount in A is, keyword here is, 2 times what is in B. Okay. Then it says if 30 states join the United States, so if 30 is the value of A, so 30 is equal to 2 times B, then which of the following equations is true if X is the number of states in for part B? So we're actually going to change the B to an X. So we're looking for which equation is the same thing as 30 equals 2X. That would be B. You can see kind of how I broke it down. I made my own variables and then I used their values to plug it in to make sense out of this. Okay, number 5. So if we have 5 over x equals 15 over x plus 20, what is the value of x over 5? Best way to do this, guys, is cross multiply. You get 5x plus 100. If I multiply 5 times x plus 20 equals 15x. Subtract 5x, subtract 5x. You get 100 is equal to 10x. So x is equal to 10. So if it asks you guys, what is x divided by 5? You're not using the 10 because you actually have to answer their question. Remember that is an easy mistake. Their question is x over 5. So what is 10 divided by 5? That answer is 2. Okay, number 6. So I'm happy to say that most people did okay on this one, except there is a faster way to do it. So I'm going to actually show you guys both ways. The first way is, of course, not so convenient, but the second way is way better. So the first way is actually using the systems and trying to solve for x and for y. So what you're going to have to do is you're going to have to multiply the top one by 3, for example, and multiply the bottom one by -2. That's going to give you 6x minus 9y equals -42. And -6x plus 4y equals 12. And you can see the numbers are doable, but they're not nice. So what's going to happen is these are going to cancel. I'm left with -5y equals -30. So y is equal to 6. But then I have to go back and figure out what x is, and then go back and then figure out what x minus y is, which is totally doable. However, let me show you guys a faster way. Because again, eye on the prize is what is x minus y? So if I take those two equations, 2x minus 3y equals -14, and 3x minus 2y equals -6, you can kind of already, by looking at these, see, wait a minute, they're kind of the same, right? So what I'm going to do is I'm going to just straight up add them as they are. Why do I do that? Because I get this, 5x minus 5y equals -20. So what does that result in? I have to divide everything by 5. Because if I do that, what am I left with? X minus y equals -4. You can see they didn't actually care about me solving all the way. I can do that, but there's no intention to do that because there is a faster way. If you look at the problem as a whole, then you know what the correct answer is. Okay, number 7, the function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be the factor of f of x? So anytime we have something that's a factor, what we do know for sure is if we plug in that number, we get 0. So that is a general rule. So as a result, I'm wondering, okay, if I plug in x equals 2 into this, I will get 0. But what happens when I look at the table when I say x equals 2? Do I get a 0 here? No. So it can't be A. There is no 3. How about x equals 4? If x equals 4, yes, I get a 0. And then if x equals 5, no. Again, the idea of a factor is that if I plug in that number, it'll equal 0. For example, let's say you have this quadratic, x squared plus 7x plus 10 equals 0. If I factor it, and I have x plus 2 times x plus 5 equals 0, okay? Well, me solving this, I take x plus 2 is equal to 0, and I subtract 2, so I get x equals -2, and I get x equals -5, okay? So -2 and -5, if I plug those into this equation, then I get 0, and that's because these two are factors. So for that same result, I don't know what the actual polynomial of f of x looks like, but I know that there's an x minus 4 somewhere in there, because if I plug in 4 right here, the whole thing goes to 0, because 0 times anything will always give you 0. That's what I mean by a factor. A factor will always produce zeros. Number 8, the line y equals kx plus 4, where k is a constant, is graphed on the xy line. If the line contains the point CD, what is the slope of the line in terms of CD. So here's what I'm thinking. This is a line. I should know something about this line. The things I should know is that it definitely crosses through right here, 0, 4, because that is a point. Now, I don't know what the slope is. Remember, K is the value in front, and that's the slope. I don't know what the slope is, but I do know it goes through C, D, because it did tell me that right here. As a result, because I have both of those, I should be able to come up with the slope from 2 points. The idea is slope will always equal y2 minus y1 over x2 minus x1. So if I do d minus 4, of course, the y2 minus the y1 over c minus 0, that simplifies to a. Okay, moving on to number 9. In the system of equations above, k is a constant. X and y are variables. For what value of k will the system of equations have no solution? So these are both lines. That's already a kind of like, just by looking at them, you know it's just x and y, no squareds, no square roots, nothing special. They're just lines. For what value of k will the system of equations have no solutions? Well, in order for that to happen, the two lines can never meet. And if the two lines never meet, that must mean they must be parallel. And one property about parallel lines is they have to have same slope. Okay, so what I'm going to do is I'm going to solve for y, and I'm only going to care about what's in front of x because that's the slope. So if I take kx minus 3y equals 4, I'm going to subtract kx because I'm trying to solve for y again. And again, I don't care about this plus 4 because sorry, that should be a kx, not a 3x. Again, I don't care about that 4 because I only care about what's in front of x because I only care about the slopes because I need parallel lines to have the same slope. So then I'm going to divide by -3, divide by -3. I can divide by -3, but again, I don't care about that part. So then y equals k over 3x plus something. Who cares? This is the slope of the first line. M equals k over 3. Okay, now I'm going to find the slope of the second line. So let me get rid of this work. The second line is 4x minus 5y equals 7. In order to solve for y, I have to subtract 4x, subtract 4x. Negative 5y equals negative 4x plus 7. Divide by negative 5. And I get y is equal to 4/5 x. And again, I don't care about that number because only the slope matters, which is 4/5. So the slope here is 4/5. So finally, where does all of that take me? Well, if these two lines never cross, they have to have the same slope. So therefore, the slope of one line equals the slope of the other line. And what you can do is cross multiply. So k times 5 is 5k. 3 times 4 is 12. Solve for k by dividing by 5. Number 10, in the xy plane, the parabola with the equation y equals x minus 11 squared intersects the line with the equation y equals 25 at 2 points. What is the length? So the best thing to do is to understand when there is an intersection, the x's are the same, the y's are the same. So if the y's are the same, which it says y equals 25, I could plug that into this equation. And I get 25 is equal to x minus 11 squared. Now, how do I get x by itself? I want to square root both sides. I am not allowed to forget about one of the most important rules about when you square root an equation, you get plus or minus 5. As a result, what does that mean? You have x minus 11 equals 5, x minus 11 equals negative 5, and you want to solve those separately. So I get x is equal to 16, and I get x is equal to 6. And if I look at these two, how far apart are 6 and 16? They are 10 apart, because what is the length of from A to B, from the 2 points? Okay, number 11. In the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? So one thing that you have to recall from geometry is something called vertical angles. If two lines meet, no matter what, this angle and this angle are the same. This angle and this angle are the same. You can kind of see it's like a reflection. So I don't like to draw the little arcs. I like to do this. Triangle, triangle. Circle, circle, square, square. Because they're all vertical angles. Why do I like to do that? Because it's less messy and it's perfect for this. So if I take x, so square, plus y, which is triangle, equals u, which is triangle, plus w, which is circle, I can see I can cancel out the triangles, and I'm left with square equals circle. So really that just means all the circles are actually squares. Now I can see these four angles happen to be all the same, and these two angles are the same. Okay, but I don't know that the yellow and the pink ones are going to be the same. So I go through it and I say, okay, does x equal z? Yes, they're both yellow. Does y equal w? No, one is yellow, one's pink. And does z equal t? Yes, they're both yellow. So the answer is 1 and 3. This is a better version of me figuring, like drawing in these arcs, because I think this would just been like messy. So, and it helps me use those values or those letters for the algebra to show that symmetry. All right, number 12. In the quadratic equation above, a is a non-zero constant, and the graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to d? So I think this is the easiest way to do this. So if it's the vertex, that means it's the highest or the lowest point in the parabola. So what I'm going to do is I'm going to try to draw what this parabola looks like. Now, I know a few things. I know, and then this is similarly based on that discussion we had earlier, I know this is our parabola right here. Why do I know it goes through -4 and 2? Well, because of the factors here. If I plug in a 2 into that first one, the whole thing is going to equal 0. And if I plug in a -4 into the second one, I know the whole thing equals 0. Why does that help me? Because that helps me figure out where's the lowest point. So what is the halfway point between -4 and 2? I take -4, I take 2, and I half it, or like average it, add them up to divide by 2. That gives me -1. So I know the x value is -1. So what's the y value? The y value is what I'm going to get once I plug in -1 into x. So I'm going to take x, -1 minus 2, -1 plus 4. That's going to give me a times -3 times 3, which is -9a. Okay. This right here is called intercept form. It's actually telling me exactly where the intercepts are of the quadratic function. Okay? Okay. 13. 13, I like this question because it looks really, really bad, but it's actually not bad at all. Here's why. You look at this and you're saying, I hate fractions, which is perfectly valid. What do we do when we hate fractions? We actually are going to multiply by whatever the LCD is. In this case, you can see the LCD is just ax minus 2, and help us figure out what is the value of a, and et cetera, et cetera. So if I multiply something by ax minus 2, it's going to cancel out the ax minus 2 here. So what am I left with? 24x squared plus 25x minus 47. What's going to happen if I multiply ax minus 2 to this thing? Because this thing is kind of standing alone. I'm going to say this equals -8x times ax minus 2. What happens when I multiply by -3? It's going to be -3 times ax minus 2. And what's going to happen when I multiply by -53? Again, those denominators are designed to cancel each other out. So as I'm distributing this to here, this to here, this to here. This is just going to leave me with minus 53. So if I clean up the right side, because the right side's still kind of messy, but the left side looks clean, I get this. 24x squared plus 25x minus 47 is equal to, let's see, distribute this, 8ax squared plus 16x, and then distribute here, minus 3ax plus 6 minus 53. Now you can see a couple things. This is the only thing with x squared. This is the only thing with x squared. I can automatically assume that those two things have to be equal. So that means 24x squared has to equal 8ax squared. You're not going to be able to make up x's where they don't exist. So you can't make up an x squared if it doesn't exist. It doesn't exist here. It doesn't exist here. So therefore, if you look at these, the x squareds cancel. 24 equals 8a. What does a equal? A has to equal 3. That's the best way to do that one. Number 14, let me quickly get rid of my work from here. So at the beginning of this video, I gave you guys the quadratic formula. Unfortunately, that's the best way to solve this one. Now, before I do that one, I look at this and I say, can I simplify this? Absolutely, you can take out a 3. And when I take out that 3, I don't need it anymore because I don't need anything that doesn't have an x on it. So the quadratic formula is, again, let me just get rid of my work from here, is opposite of b plus or minus square root b squared minus 4ac divided by 2a. And if I plug everything in, I get b to equal 4, so opposite of 4 plus or minus square root 4 squared minus 4 times a is equal to 1, c is equal to 2, so 1 times 2, all over 2 times 1, so just 2. Now, it's not too bad to try to clean up the inside. That's just 16 minus 8, which is equal to 8. So that's negative 4 plus or minus square root of 8 over 2. Now you can see that's none of these answers right now, but I do see that square root of 30 is too big, and I don't see a 6 anywhere really. I just see negative 4 and 2. So what I can do now is I can actually reduce the square root of 8. What's the square root of 8? Square root of 8 can be broken up into root 4 root 2. So that's 2 root 2. So this turns into negative 4 plus or minus 2 root 2 over 2. And how do those three things reduce? You can take a 2 out of both of them. So I'm left with negative 2 plus or minus root 2. And I believe that is answer A. Only way to really do this one is the quadratic formula. So unfortunately, guys, if you are not good with the quadratic formula, that is something you want to practice. There's a nice section in your big SAT booklets that talks about the quadratic formula. Go ahead and refer to that one for more practice. All right, and finally, number 15. So this is the formula to convert from Celsius to Fahrenheit. The equation above shows that a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? So I look at these and try to explain to me how to convert from one to the other. Well, if I look at this and I say, what is an easy number to plug in for F? You would hopefully say, if I see this F minus 32, we should just plug in 32, because what's 32 minus 32? I get 0. And if I get C is equal to 5/9 of 0, then I know when the Fahrenheit is 32, the Celsius is equal to 0. Okay? I'm going to start with that presumption. So then I'm going to ask myself this. Is it true that the temperature increases 1 degree Fahrenheit is equivalent that the temperature is increasing 5/9 degrees Celsius? Let's see what happens. If I plug in 1 extra degree Fahrenheit, what's going to happen in this equation? I get C is equal to 5/9 times 33 minus 32, which is equal to 1, which means C is equal to 5/9. Okay, so that means that has to be true. 1 degree Fahrenheit increase is equivalent to 5/9 degree Celsius. Okay, so now I'm going to ask myself, is Roman numeral 2 correct? A temperature increase of 1 degree Celsius is equivalent to the temperature increase of 1.8 degrees Fahrenheit. Well, what we can do is we can try going backwards and saying, okay, what happens if I increase the temperature of Fahrenheit 1.8 degrees? Well, if I, instead of adding +1, I instead add plus 1.8, I would get Fahrenheit is equal to 33.8. So let's see what happens when I plug in this number into here. C is equal to 5/9 33.8 minus 32, which gives me 5/9 of 1.8. There's that 1.8 degree increase. Now, what's 1.8 times 5/9? Well, let's see if we can convert 1.8 into a fraction. 5/9 times 18/10. All right, we can reduce 18/10. That's the same thing as 9/5. And if you notice, if I multiply these, they actually cancel out, and I'm left with 1. So if the Fahrenheit is 33.8, Celsius is 1, so that must be true because I got an increase of 1 degree Celsius. So that's true. I don't even need to test number 3 because that goes completely against what number 1 is saying. A temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. No, that's kind of going against what I just said in that one. Also, if 1 and 2 are already figured out to be true, so 1 is true, 2 is true, well, there is no 1, 2, and 3, so there's no reason to check number 3. Okay, the correct answer must therefore be D. Okay.